Good evening, my fabulous science students. I'm just going to give you a quick little tutorial about the periodic table using the notes that I've put in Classroom for you. Um, I'm going to take this time and just explain a couple of components of the periodic table, show you the periodic table that we are going to use. I think it's the best one that we have, just to give you a little bit of extra insight and help you as you work your way through this next part of our chemistry unit. So anyway, the periodic table is an incredible device that the image that you're seeing right now is actually not even a current one in the spreadsheet that I have. This is the one that was in there. But down below here, this final row has actually been completed. And so when you see the actual periodic table, this is the one that I have for you that I want you to use. And it's actually, I think, an even much better version of it. Nice, crisp, and clean, color coded. I'll be going back through this in just a little bit. So let me just give you a little bit more about what this is. Periodic table, as we know, was developed by Dmitri Mendeleev back in the 1860s. It is an organizational system. It allows us to categorize the elements based on certain properties and by their sizes as well. So between the work of Dmitri Mendeleev and Henry Moseley, we have this system which we use even to this day. Mendeleev, obviously, as you saw, if you took the time to go through the Mystery of Matter videos, Mendeleev was working with 63 elements in 1869 when he made his rather remarkable discovery that weekend that he spent trying to actually get a start on his second chemistry textbook because he was teaching a class at the university. Anyway, over this weekend, he actually created a pattern or a system actually using the patterns that he noticed with the different elements, and he arranged them by their atomic weights. But not only just in one big long line, he noticed that periodically certain elements in certain families would show certain characteristics, and they would also have a pattern of difference between one row and the next row of that element. And so he noticed that there's actually there are secrets to be found in the horizontal rows and the vertical columns of his periodic table. And so that's what put Mendeleev on the map. He also, amazingly, was able to predict the existence of future elements based on what his periodic table showed him. So he actually left those blank in the periodic table at the time those elements hadn't been discovered. And within the next 15 years, the three elements that he predicted would be discovered were in fact discovered, which, in my opinion, is one of the greatest discoveries, basically confirming the work that he did. So when we talk about the periodic table, I'll explain a little bit of this, and then I'll go to our better periodic table so I can show you. It's arranged like a grid. You've got vertical columns, horizontal rows, like I said, and the elements in this grid are specifically located from left to right and from top to bottom. All right. The rows, which is the left to right horizontal line of elements, is very specifically organized, and each element is in its proper place and has a reason for being there. Same thing goes with the vertical columns. From top to bottom, the elements that fit in those vertical columns, there are certain characteristics of those elements that decide where they go. So when we're looking at the periodic table of elements, I'll kind of just show you through there. If you notice the top row, there we go, you can see a little bit better. The top row has only two elements, hydrogen and helium, all right? That's not a mistake. When I was a kid, I always wondered why this was this huge gap in the periodic table. That wasn't somebody's error. This is the way these elements played out as far as where they go, their properties. These are the two lightest elements. There are only two on that first row. We call it a period. I'll get to that in a minute. And then you move down to the second row or the second period, and now you're up to 8 elements for the second and third periods. It's not until you get all the way down to the fourth period before you actually fill it with a full row of elements. And when you get down to the sixth and seventh period, these two down here, you'll actually notice there are some gaps here. 57 to 71, if I zoom this in for you to see. 57 to 71, these are what are called the lanthanides. And so there's 57 all the way through 71 there. And then in the seventh period, you've got 89 through number 103. Those are called the actinides. So there's 89 all the way through 103. This series down below here, these are called rare earth metals, and they were actually plucked out of period 6 and 7 and made into their own separate little section by Glenn Seaborg. He didn't change the order of any of the elements. He just reorganized where they should sit on the document. That way everything could fit on one page. So going back to our notes, let's see here. So you've got the periods, like I said. These are the horizontal rows, all right? 2 in the first one. There are 8 in the second and third periods. There are, whatever that is, I think that's 16. Is that right? 4, 5, 6, 7, 8, 9, 10. Oh, no, that's 18 for these, the third and fourth periods. I'm sorry, the fourth and fifth periods. Sixth and seventh periods have a whole lot more, all right? Now, what does it mean when, depending on what period the element is in? That tells you how many, they're called atomic or orbitals. When we focus on the atomic orbitals, we're talking about where the electrons are on the outside of that particular atom, all right? So the period, or the row, rather, that the element is on will tell us how many orbitals, or how many circles go around the nucleus of the atom, and those circles each contain electrons. So for instance, if it's in the top row, like I said, hydrogen and helium, there is only one orbital for its electrons. It has a very small amount of electrons. Those electrons go in that first orbital. We also call them electron shells. That's another way of putting it as well, all right? The elements of the second row, I told you there were 8 of those elements. They all have 2 orbitals for their electrons, and it follows a pattern like that. All right. So going to our periodic table once again, I will show you. All right. So there's hydrogen and helium. Being that it's in the first period, those are the numbers you will see on the far left. So these numbers right here, there's 1, there's 2, 3, 4, 5, 6, and 7. Those label whatever period that element is on. So like we said, hydrogen being in the first period, which is the first horizontal row, will have a single atomic orbital, or an electron shell, we call it, and that's where the electrons will go. We will spend a whole lot more time learning about the outside electrons and the orbital shells next week when we start building Bohr diagrams and Lewis structures, all right? So let's go and talk about the groups and the families. So along with a period, 7 periods for the periodic table with all the elements located somewhere there, you also have what are called groups or families. You could use either word, group or family, and those are the vertical columns. So you'll see the very first one, it's marked here in red. That's actually a group called the alkali group. Those are all metals. They are highly explosive when they come in contact with water. That includes elements like sodium, lithium, potassium, all the way down to francium, which is the most reactive metal in the periodic table. Vertical columns all the way down. So you'll see all these vertical columns. What does it tell us? So depending on its column or its group slash family, all right, that will tell you how many electrons are on the outer orbital. I was telling you about those atomic orbitals, or those circles that go around the nucleus of the atom. Um, the number of electrons that are found on the outside orbital is determined by the group or the family. All right. So every element in the first column, group 1, the alkalis, like I was telling you, has a single electron in its outer shell. Even a really big element like francium, which has 87 electrons altogether, francium has only one electron on that outer shell. You go to the second column, or the second family. Those are called the alkaline earth metals, and those actually have 2 electrons in their outer shell, and so on. So based on the column that it's in, that will tell you how many electrons are on the outside. So if we go back to our periodic table and we take a look, now I can zoom in and show you the numbers above. So this number means that it's the first column. This number means that it's the second column. These yellow ones here are called transition metals. 3 through 12 are those column numbers there. All right. Now this is where it gets a little tricky, but not too much. This is column 13, the boron group. Carbon group is 14, nitrogen group is 15, oxygen group is 16. Then you have what's called the halogens, which is a group of nonmetals, all the way from fluorine all the way down to tennessine. And then, of course, hopefully you learned or you paid attention in the Edpuzzle video and learned about the noble gases, which was that final group that Mendeleev added to his periodic table once they were discovered after he had published his original one. This group of noble gases, they're actually marked in purple. All right. Now, we'll get into a little bit more detail about this next week when we do Bohr diagrams, and I will show you how to read these numbers to help you determine what's on the outside shell. One final thing I wanted to focus on in our notes for this first part, we're only going through these first 10 slides, is the actual cell itself inside the periodic table. Each box is considered a cell, like in a spreadsheet. All right. That cell or that little placard or the little box with information, however you want to call it, label, I guess you can call it, has individual pieces of information. There's 4 of them. In the periodic table that we use, 4 of them. The number that's on top, which on our periodic table was actually up in the corner. All right. That's the atomic number, which is the number of protons inside the nucleus of that atom. That atomic number was, of course, discovered by Henry Moseley when he was able to compare the different frequencies of the positively charged particles in the element. Then, of course, the big letter is the symbol, and it's either going to be 1 or 2 letters. I cannot stress this enough. The first letter is always capital. Always capital. You never capitalize the second letter. In this case, carbon only has 1 letter, so it's capital. But if you use a different element, you will notice that the first letter is capital, the second letter is lowercase. I stress for my students to remember that. These symbols refer to the element's name or its original name, which may come from a different language. Then you have the name of the element, which appears right below the symbol. And then the thing on the bottom is the atomic mass. Sometimes it's considered the atomic weight. This is when you add protons and neutrons together, and you get, these are what are called 12.011 atomic mass units. That's the number that's going to be at the bottom. This number is not always going to match this number. As a matter of fact, this number will always be bigger than this number because this number refers to only the protons. This number refers to the protons and the neutrons together. So let's go ahead and dive into our periodic table for a quick moment here so you can kind of see what I'm talking about. Going to carbon there, that's the one they just showed us. There's carbon, like you just saw. There's your number. It's just to the left a little bit. There's your symbol. There's the name of the element. And there is the atomic mass. You can notice, like I said, if it's 2 letters, like silicon here, first letter is capital, second letter is lowercase. And then this is a little key that helps you. I want to show you one final thing about this periodic table because, guys, this is a tab that I think you should have open pretty much for the next 3 or 4 weeks on your Chromebooks because you're always going to be referring to this periodic table. I don't expect you to memorize all of these, guys. There's 118 of them, and I'll be totally honest with you. I don't know every single element. I've heard of every single one, but if you asked me where iridium was, I'd have to find it. It's actually right there. But if someone just came up to me and asked me what atomic number iridium was, I wouldn't be able to tell them. But can I find iridium? Yes, I can on the periodic table. So I want to teach you how to use this document, right? On the bottom, you will notice these boxes with their different colors, all right? Alkali metals, like I said, are the red ones in the far left, okay? If you're looking at orange, that's the alkali earth metals. That's the second column, all right? All of these yellow ones, this big section right in the middle, those are called transition metals, okay? For our purposes in 8th grade chemistry, we really skip over the transition metals. We won't really learn a lot about like the mechanics of them. I just want you to know that they are metals that you undoubtedly have heard of. Gold, there's silver, copper, nickel, iron. I know you've heard of those types of metals before. Titanium, good for making good material for bicycles, things like that. All right. Green are your basic metals. And you will notice that these are green right here. It's just this section right here is basic metals, all right? Then you have what are called metalloids. These ones, I'll zoom in a little bit because you got to kind of see the difference. It's not really green like aluminum. It's more of like a greenish, turquoise-ish type color. And that goes down through here. The metalloids are this section right there, all right? One mistake on the periodic table, germanium should not be blue. It actually should be green because germanium is a metal, all right? Then you've got the nonmetals, which are your typical gases that I know you've all heard of before. Carbon, nitrogen, oxygen, phosphorus, sulfur. These are common elements that that make up Earth, a lot of parts of Earth, all right? Then you get to your halogens, which is the dark purple. These are also gases, fluorine, chlorine, all the way down. And then, of course, your noble gases are on the far right. Those are helium all the way down to the largest element of the periodic table called oganesson. And then, of course, the lanthanides and actinides, like I showed you before, these are called rare earth metals, and they were placed down here below the main periodic table by Glenn Seaborg back in the 1940s. Right? That's just an overview of the periodic table. We're going to spend a lot more time in this document learning about it. You will have a periodic table scavenger hunt. You're going to have to do some searching through here to locate elements, to look at their atomic number, to maybe determine what their atomic mass is down below. I want you to use this document here. So like if you're asked what the atomic mass for carbon is, I want you to put precisely 12.011 because that's the atomic mass that appears on this periodic table. And this is what I consider our class periodic table. All right, guys, so that's it for part 1 of our notes. I will be going through the second half of the notes on a video that will appear later on this week. All right, so we have gone through the first 10 slides. Those ones that I just showed you, Mendeleev, how it's arranged, talking about periods, talking about group and families, and then talking about the how to read the periodic table for each element. All right? I will talk to you guys later.